Hello everyone, my name is Kishan Agarwal. Today I'm going to present my AAT Tech Talk of Web Application Development, and my topic is Advanced Mathematical Library for JavaScript. So let's begin. First of all, introduction to JavaScript. JavaScript has evolved beyond its web development roots, becoming a versatile language for various applications. As we know, it is a client-side verification language. It has multiple libraries, and basically we are going to discuss about the advanced mathematics library, which is in JavaScript, which plays a crucial role in various domains, including data science, machine learning, as well as scientific computing. So JavaScript's native math capabilities are limited, necessitating the use of external libraries. So math.js is a JavaScript library that brings advanced mathematics to the web browser and server. And so we are going to discuss a case study in this tech talk that is demonstrating the case study of rocket trajectory and how to optimize it. So there are several benchmark comparisons with other JavaScript libraries and state-of-art mathematics software are presented. And the current challenge that is faced by math.js, including performance, sizes, and also time complexity. So JavaScript has been around for 24 years, 21 years from now. So during most of its early lifetime, it was used only to create simple interactive elements in web pages and do basic animations. So JavaScript was seen as a toy language because of its lack of strict typing and for not being a true object-oriented programming language. As we know that JavaScript is a object-based programming language, not object-oriented programming language. So the release of Firefox in 2004 and Chrome in 2008 brought a period of competition among the various browsers vendors, with each striving to attract more users through new and improved features. Innovation included drastical faster JavaScript and HTML engines. Over time, web design also evolved. The static web pages of the past steadily gave a way to rich, fully featured web applications. So, as we can see in 2009, the development of Node.js revealed interest in the language by enabling JavaScript to run on server platforms as well as in browsers. Developers were then able to build full stack applications using a single language on the client and server sides. Innovation did not stop there. JavaScript can now be used to create cross platform desktop applications and power Internet of Things hardware, that is IoTs. It can be used a query language for database. Now, these innovations have attracted one of the largest and fastest growing software communities ever seen. So, the culture is heavily influenced by open source concepts, including the philosophy to release early and release often. This high rate of innovation and churn is facilitated by JavaScript's excellent package manager and has resulted in very dynamic ecosystem containing many high quality software packages. So this we have seen that although JavaScript's popularity is increasing, it is typically not a programmer's first choice for doing advanced mathematics. Its performance has improved drastically in recent years, but still it is easily outpaced by languages such as C and Fortran, especially for performing intensive numerical calculations. So, however, if the programmers aim to reach the largest possible number of users, he or she must be able to mobile and web apps. The web is powered by JavaScript. So writing math-related applications for the web require an advanced JavaScript math library. And that's where math.js aims to make advanced mathematics available for JavaScript community. Before that, lack of comprehensive mathematical functionality in JavaScript standard library. So why we require math.js is the three reasons. Need for a library that supports a wide range of mathematical operations and data types. Desire for a library that is performant, well documented, and actively maintained. So math.js aims to make advanced mathematics available for the JavaScript community. So most programming languages support only basic mathematics out of the box. For mathematicians, however, this is not significant as evidenced by the need for powerful tools such as MATLAB, Mathematica, or we can say Maple and R. Some programming languages such as Python do have excellent support for mathematics thanks for the NumPy and SciPy libraries. Until recently, the options for advanced mathematics in JavaScript were limited. So math.js was not the first, nor it's the intended to be the last JavaScript library for advanced mathematics. A number of other great math libraries for JavaScripts are also worth mentioning. For example, for vector and matrix calculation, the best known library are ND-Array and Sylvester. Calculations with complex numbers can be done with complex.js library, and some numerically oriented libraries are number.js and numeric.js, both which supports matrices and complex numbers. So these are the other math libraries other than what math.js. So let's deep go deep into what is math.js and look at some history of math.js. So long before the first public release of math.js, one of the author created a small calculator application named SpeakU Mathematics. This project started in 2003 and was written in basic languages. The aim was to create an application to fill the gap between simple calculators included with an operating system and the heavy-weighted mathematics applications like MATLAB and Mathematica. So the application featured basic arithmetic, complex numbers, units, graphical plotting, numerical integration, and differentiation and more. So over time, the application had been rewritten in C++ and Java, and eventually was released as a JavaScript web app called Math Notepad. Math Notepad turned out to be much easier and faster and more fun to develop than earlier iterations of application. In 2012, it was really realized that the math engine inside Math Notepad was very valuable on its own. The entire math engine was separated from the user interface and launched in 2013 as the open source library that is math.js. So math.js is an extensive JavaScript library that brings advanced mathematics to the web browser and server. It provides a comprehensive set of functions and data types for performing complex mathematical operations. Math.js is open source as well, documented and actively maintained by a large community of developers. What are the key features of uh, math.js? It supports a wide range of mathematical operations such as calculus, linear algebra, statistics, which are mostly used in data science and machine learning. It handles various data types, including numbers, complex numbers, fractions, matrices, and units. Next, it is also flexible expression parser, that is enabling symbolic computation and evaluation of mathematical expressions. Supports user-defined functions and also custom operators for extending the library's capabilities. It is also cross-platform compatible. That means it can run seamlessly in web browsers, Node.js environments, and JavaScript-based applications. Provides a consistent API across different platforms, ensuring portability and ease of use. So that were the key features of math.js. Now we'll see applications in different fields. First field is data science and machine learning. Perform data analysis, feature engineering, and model training using advanced mathematical techniques. Leverages math.js matrix operations and statistical function for efficient data manipulation and analysis. Next is scientific computing. It solves complex mathematical problems in physics, engineering, and other scientific disciplines. It utilizes math.js calculus and numerical analysis capabilities for simulating physical phenomenon and solving differential equations. Next is graphs and visualizations. Create interactive visualizations and animations using mathematical transformations and geometric calculations. As well employ math.js vectors and matrix operations for efficient rendering and manipulation of graphical elements. So the case study which we are supposed to do, that is rocket trajectory optimization. So how that can be done? Demonstrate the flexibility of math.js by extending the library to solve optimize a rocket trajectory problem. It will highlight the library's ability to handle complex mathematical operation and real-world application. Benchmark comparisons. So what are that? Comparing the performance of math.js against the other JavaScript math libraries which we have earlier discussed, numeric.js or number.js and all, that evaluates the library's efficiency and suitability for various computational tasks. Now, future work. Performance optimization and community engagement are the main future work that math.js require. Continuously improving the performance of math.js algorithm and data structures, and also exploring the parallel hardware acceleration techniques for enhancing computational efficiency. Next is community engagement. That means expand the library's documentation and tutorials to enhance its accessibility, because most of the people don't know what operations are included in that library. So proper documentation and tutorials may help in expanding the community, which will also foster a vibrant community of users and contributors to drive further into the development. So what we have seen, math.js has emerged as a powerful and versatile advanced mathematics library for JavaScript, and also it is continuously growing. That means continuously changes, development is made in this math.js. Thank you.